Morning students. Today we'll learn about the next topic of electricity. Okay. Yesterday what we learned, let us recapitulate a little bit of that thing. So what we learned, what is electricity, types of electricity, that is static electricity and current electricity. Static electricity is study of charges at rest, whereas current electricity is study of charges at motion. Example of static electricity, you rub a plastic scale with your hair, okay, then if you keep it near towards piece of papers will be attracted towards the plastic scale because that plastic scale gets charged. And current electricity means a conductor is connected in a battery or a cell so that electrons will repel the electrons of the metal or conductor. So the electron starts moving. The motion of electrons are nothing but motion of charges. So the charges are in motion, we call them as current electricity. Because of that, an electric current is induced in the circuit that we represent as I, but actually I is electric current and it is induced because of motion of electrons. Okay, that is motion of charges. So electric current is denoted by I. Electric current is denoted by I. The formula of I is I equal to Q by T. Right? Q means charges, T means time, I is electric current. Charges already explained, intrinsic property of an atom. Okay, and it is SI unit of charges, coulomb. Then it is represented as C. Okay, time is second, I is represented as ampere, and current is measured by an instrument called ammeter, which is always be like this, plus and minus. Okay, that is ammeter, which is always connected in series with the instrument in which we are measuring the current. Okay, so this all we learned. Okay, this all we learned yesterday, and we also learned when the current is said to be 1 ampere. So you can check through the last video, please. If you have not watched the last video, just go through the video, watch it perfectly, and then come back to this video. Don't come to this video without watching the first video because you will not understand. Okay, today we'll learn about remaining things. Before that, let me tell you, 1 coulomb of charge, 1 coulomb of charge or 1 C of charge, we can say, 1 coulomb of charge contains 6 into 10 to the power 18 electrons. In 1 coulomb of charge, there are 6 into 10 to the power 18 electrons are present. For you have to say there is 1 coulomb of charge is flowing. That means in that there is an array or a group of 6 into 10 to the power 18 electrons are flowing. Okay, so 1 coulomb of charge constitutes or it has 6 into 10 to the power 18 electrons. This much number of electrons, remember this is very much important number, 6 into 10 to the power 18 electrons constitute 1 coulomb of charge. Okay, then in electron has a charge on 1 electron, charge on 1 electron is minus 1.6 into 10 to the power minus 19 coulomb. This is the charge on 1 coulomb of electron. Sorry, this is the charge on 1 electron. 1 coulomb of charge is 6 into 10 to the power 18 electrons are present. But in 1 electron, 1.6 into 10 to the power minus 19 coulomb charge is present. So, since electrons are negatively charged, we use minus symbol here. Sometimes this is not used just to say that it is having magnitude of 1.6 into 10 to the power minus 19 coulomb. but this minus indicates electrons are negatively charged. So minus of 1.6 into 10 to the power minus 19 coulomb is the charge on each electron. So similarly, charge on each proton is same, 1.6 into 10 to the power minus 19 coulomb, but it is plus. You know what is proton, electron and neutron, and obviously neutron is having no charge. So here charge on one electron minus 1.6 into 10 to the power minus 19 coulomb. Charge on one proton 1.6 into 10 to the power minus 19 coulomb, but on proton positive charge, on neutron negative charge. This is regarding charge. So how do you say 1 coulomb of charge? So I have the formula. You should remember this formula. Q is equal to N into E. It has to come 1 coulomb. See, N, what is N here? 1 coulomb of charge having 6 into 10 to the power 18 electrons. 6 into 10 to the power 18 into electron. What is charge on 1 electron? 1.6 into 10 to the power minus 19. Right? 6 into 10 to the power 18. 1.6 into 10 to the power minus 19. Okay. Now 6 into 1.6 is, if you make, it will come nearly 10. Okay. Into 10 to the power minus 1. See, here we are not considering minus because we are considering only the magnitude. This minus indicates that is negatively charged. It doesn't mean that this value is negative. This minus indicates it's a negatively charged. That's it. So 10 into 10 to the power minus 1 is nothing but 10 into 10 to the power minus 1 can be written as 10 into 1 by 10. So we will get 1 coulomb. So Q is said to be 1 coulomb if it has 6 into 10 to the power 18 electrons. Understood? So Q is said to be 1 coulomb if it has 6 into 10 to the power 18 electrons. So you can even consider this as 1.6 into 10 to the power minus 19 coulomb also. Since electron is negative charge, sometimes we use it as minus. Okay, then we'll go to the next concept. Before that, we'll show you how a circuit diagram will be. A normal circuit diagram will be like this. Basics of a circuit diagram. Okay, this is connected. This is what? Battery. Here I am using 2 cells. You may use 3 cells also sometimes. So here I will tell you what is key and all in the next class. Okay, this is plus, minus. So plus should be connected to the plus of ammeter. Minus should be connected to the minus of ammeter. So, and in an electric circuit, always current direction has to be shown. I already told you current is always from positive to negative. Positive is here, negative is here. So conventional flow of current is always from positive terminal of the battery to the negative terminal of the battery. That means positive to negative. So this is the symbol of flow of current. Actually electrons are flowing by this side, but for conventional we are showing positive to negative. Whichever circuit you draw, you have to first indicate, after drawing the circuit, you have to first indicate flow of current, in which direction it is flowing. I is flowing in this direction. And remember, ammeter's positive side should be connected to the positive of the battery. Negative of the ammeter should be connected to the negative of the battery. These two things you should not forget. Okay? So next we will learn about, just draw it down. Okay, you can pause the video and draw it down. Or if you want some time, I will give you can draw it down. Okay. Much you understood, I hope. Now we will move to the next one, that is electric potential and potential difference. Electric potential and potential difference. Electric potential and potential difference. What is electric potential? So electric potential means, see, it is the potential of electrons. Normal thing. Potential in the sense we can say it is the amount of energy. So the potential energy of dam. So for example, if you take Almaty Dam, the water potential of Almaty Dam is more compared to the water present in our river, whichever river you take. So you are in Mudol means Mudol river, if you are in Galagali means Krishna river, whichever river you take. So the potential of water is more compared to the potential of water of the rivers. So potential means it is the amount. Okay, suppose if you are in your 10th standard, there are 28 students, right? If in the ninth standard there are 25 students, then the potential of 10th students is more. So it is nothing but the amount. So here electric potential means electrical energy potential, electrons potential, and potential difference. So before understanding this, let us tell you one experiment. So suppose if I take two tanks, this is one water tank and another water tank I will take. This is to understand potential difference. To understand potential difference. Okay. So one water tank is present and another water tank is present. I will connect this to a pipe. Okay. So in this water tank, let me say A and this is B. In this water tank, if I put amount of water, P here, okay, and if I put amount of water P here, same, okay, same in the cases of both the tanks. Now, is there any flow of water? No. There is no flow of water between tank A and tank B because the amount of water present in A is also same, the amount of water present in B is also same. Now I will decrease the amount of water in B. So now there will be a flow of water. Definitely there will be a flow of water from A to B. That means water flows from higher pressure to lower pressure. Here the pressure is more because volume is less here. Value means the vacant place, that is less. Here vacant place is more, hence pressure is less. So it flows from higher pressure to lower pressure, or you can say it flows from higher potential of water to lower potential of water. Okay, so when it flows from higher potential to lower potential of water, then we must understand that there is a potential difference between these two. The similar thing we can tell it to the electrons. Okay, suppose in this tank whatever water we have considered, if you consider them as electrons, same thing will happen. At one terminal there are less electrons. Okay, in another terminal there are more electrons. Now these two terminals are connected. Okay, here less electrons, here more electrons. Now these two terminals are connected by a battery, okay, or a circuit. Then what happens? There will be flow of electrons, isn't it? There will be flow of electrons. Suppose this is, we can say, okay, we can say like this. More electrons are present, those are moving towards less electrons. Okay, that means there must be a potential difference. If same amount of electrons and same amount of electrons are here, then there is no flow of current, right? So electrons are more here and less here, so electrons will flow. Flow of electrons nothing but current. Okay, so current comes because there is a potential difference between the voltage or potential difference between the electrons. So what is potential difference then? So what is potential difference? So what is potential difference? Suppose if I make an electrical circuit, okay, this is the bulb. Okay, if I make an electrical circuit, I want a potential difference across these two terminals. Here is one point, here is B point. If I want the potential difference, just what I need to do is, I have to put 1 coulomb of charge here, unit charge, that I need to move from this point to this point. In that, how much work I am doing, that is the potential difference. See, the potential difference is given by this battery. Are you agreeing? Why? Because, listen clearly, here it is having more electrons. Negative part of battery is having more electrons. Positive part of battery is having less electrons. Okay? So, the current is moving from negative terminal, electrons are moving from negative terminal of the battery to positive terminal of the battery. Hence, work is done. Here it is, work is done. Okay, it is moving like this. To maintain that electric current, the electric current should be maintained in this circuit. To maintain the electric current, this battery will do some work. Okay, so that potential difference should also be maintained. So what is potential difference? So potential difference, definition of potential difference. Potential difference is V. Okay, what is potential difference? Potential difference is nothing but, okay, it is the amount of work done. Let me tell you the first formula. V equal to W by Q. W is work done, Q is charge. So I will keep it as 1 coulomb. Means V gone, no, sorry, Q gone, V equal to W it becomes, right? So now we can see the amount of work done in bringing unit positive charge from one point to another point in an electrical circuit. Do you understand? The amount of work done, this is the work done. You are bringing from here to here means you are doing some work. The amount of work done in bringing unit positive charge from one point to another point in an electrical circuit is the potential difference. So it is represented by voltage. So I will write it here, the definition. You have to note down with me also, and this is very much important definition. The amount potential difference is the amount of work done. Amount of work done in bringing unit positive charge from one point to another point. Unit positive charge from one point to another point in an electrical circuit. From one point to another point in an electrical circuit. One point to another point in an electrical circuit. So this is potential difference. Okay, and there is one definition for electric potential. It is not much there for your syllabus. Only you concentrate on potential difference. But let me tell you what is one definition of electrical potential. See, in potential difference, we are considering 2 points because difference means 2 points. Wherever you have to find difference, there must be 2 objects. What is the difference between your marks and your friend's marks? If you are taking 95, your friend is taking 85. What is the difference? 95 minus 85, 10. Right? So difference is always be 2 objects. What is the difference between your weight and your friend's weight? If his weight is 50 kg, your weight is 45 kg, then difference is 50 minus 45, 5 kg. So difference is always between 2 things. That means here 2 points are there, hence it is potential difference. Now what is electric potential? For electric potential, see, in an electric circuit, we will not take any 2 points because we don't know other point. Only we are knowing that potential is present here. Large number of, here is also potential is present. So other point we don't know, so we consider it as infinity. So wherever some point is there infinity, from that point to this point, if I want to move the unit positive charge, how much work I need to do, that is our electric potential at that point. So same thing, if I want to check electric potential at this point C, then I have to take a unit positive charge somewhere in the infinity. Somewhere there is a unit positive charge in infinity, and I have to bring that unit positive charge to this point C. How much work I do know? That is the potential, electric potential in that point C. So definition of electric potential. So you can note down this. I will tell the definition of electric potential and formula for electric potential difference. We will move to the next. Okay. Definition of electric potential: the amount of electric potential is the amount of work done in bringing unit positive charge from infinity to that given point. Positive charge from infinity to given point in an electrical field. One point. Okay. Under the influence of electric. There must be electric field or circuit under the influence of electric field. Influence of electric field. So this is called electric potential at a point. Electric potential at a point. Electric potential at a point is the amount of work done in bringing unit positive charge from infinity to given point under the influence of electric field. This kind of definitions you have to note it down. Pause the video, note down the definition. Okay, don't forget, simply don't go on just see watching. Pause the video and note it down in your note. Okay, and you read it again and again, make it perfect. Okay, now potential difference. See, this electric potential is also measured by V. It's also denoted by V, and this is also denoted by V. But this is electric potential, this is potential difference. Okay, for us there is not much of electric potential, this much is enough. Okay, so I will tell you about potential difference. Potential difference, already definition we know, there is a difference between the two potentials. That means if you bring, if you keep one unit positive charge in one point, you have to do some work to bring it to the other point. What is the work you are doing? That is the potential difference. The amount of work done in bringing unit positive charge from one point to another point in an electrical circuit. That is your potential difference. So potential difference is represented with or denoted with V. The formula is W by Q. SI unit of potential difference is volt. SI unit of potential difference. SI unit is volt. Keep on noting these all things. These all are important things. You have to note down this. Okay, whatever I am writing on the board, you have to note down. SI unit is volt. Then it is measured by the instrument called voltmeter. It is measured by the instrument called voltmeter. So work done is represented in SI unit of work. Work is nothing but energy, right? So work is joules, charge, coulomb. So 1 volt equal to 1 joule per 1 coulomb. That we can say joule per coulomb, right? So when potential difference is said to be 1 volt, if both are 1, so how to define that? Potential difference is said to be 1 volt if 1 coulomb of charge makes 1 joules of work in second, or if you say 1 joule of work is done in bringing 1 unit or 1 coulomb of charge from one point to other point, then we say it is 1 volt of potential difference. Understanding? You have to write all these things in your note and just refer the text which is already sent in PDF form. If you are not having textbook, we have already sent it in PDF form. So if you are having the textbook, it is already there in the textbook. You have to go through once and then attend the class. Okay. If you have any doubts, then ask in the WhatsApp group. Okay. This is regarding potential difference. Okay. Lastly, I will tell you one definition. When the current is said to be, potential difference is said to be 1 volt. It is said to be 1 volt only when if one, so I will write the formula first. V equal to W by Q. When it is said to be 1 volt, suppose if I take the circuit, only I will draw a circuit here. Okay, bulb is there. So plus minus 2 points are here, A and B. If I put 1 coulomb of charge, then I want to do this. Okay, then I am doing some work, right? So what is V equal to W by Q? Listen, if 1 coulomb of charge, that is 1 coulomb of charge. So what is 1 volt of potential difference? So the potential difference said to be 1 volt, if this was important, 1 joule of work is done. 1 joule of work is done in moving or bringing, both are same. Don't get confused. Moving you can use, bringing you can use. In moving 1 coulomb of charge from one point to another. 1 coulomb of charge from one point to another. So this is your second class. So this ends. Please note down this, and wherever you find very important definitions, wherever I told, you have to pause the video and note down. Okay? Because if you don't understand the basic, you will not understand problems. There are problems in this chapter, and one problem will be coming in your final exam. Definitely one problem will be coming in your final exam. So you have to very care about that. Okay, so please note down the definition, note down the formulas correctly, and SI units, very much important. SI unit of work is joule. Okay, I will explain all SI unit in the next class. SI unit of work is joule. SI unit of Q means charge, that is coulomb. Then SI unit of, this is V means potential difference. SI income V is volt. And the instrument used to measure V is voltmeter. It is always connected in parallel. Whereas ammeter was connected in series, voltmeter or voltmeter is connected in parallel. Suppose if I want to measure the potential difference here, I have to connect a voltmeter here. This should be parallel with the resistor or with the point where we are measuring potential difference. Okay, so this should be always parallel. So ammeter will be like this, voltmeter will be like this. Okay, it is always connected in series in which current is measured. It is always connected in parallel in which voltage is measured. See, potential difference and voltage are same. They are covered by the same meaning. Voltage or potential difference, both are same. Some people will call it as potential difference and some are call it as voltage. Right? So this is regarding your second class.